To ride a best-in-town taxi, you pay a start fee and a mileage fee. The table shows the total cost of a taxi ride for different distances. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the cost as a function of the number of miles. To determine whether the data are linear, find the rate of change for consecutive data pairs in the table. The rate of change from 4 miles to 8 miles is given by the quantity 23 minus 13 divided by the quantity 8 minus 4, which equals 2 5/10. The rate of change between 8 and 10 miles is given by the quantity 28 minus 23 divided by the quantity 10 minus 8, which equals 2 5/10. And the rate of change between 10 and 12 miles is given by the quantity 33 minus 28 divided by the quantity 12 minus 10, which equals 2 5/10. Because the rate of change is constant, the data are linear. Let C be the cost in dollars and let D be the distance in miles. Note that the constant rate of change is the slope. Use the slope, which equals 2 5/10, and a data pair in the table to write an equation that represents the data. Use the point 413. Write an equation that represents the data in point-slope form. Point-slope form is given by C minus C1 equals m times the quantity D minus D1. Substituting 4 for D1, 13 for C1, and 2 5/10 for m, gives C minus 13 equals 2 5/10 times the quantity D minus 4. Next, use the distributive property. Because 2 5/10 times D equals 2 5/10 D, and 2 5/10 times negative 4 equals negative 10, C minus 13 equals 2 5/10 D minus 10. Next, add 13 to each side of the equation to write the equation in slope-intercept form. Because negative 13 plus 13 equals 0 and negative 10 plus 13 equals 3, C equals 2 5/10 D plus 3. Because the cost increases at a constant rate, the situation can be modeled by a linear equation. The linear model is C equals 2 5/10 D plus 3.